Building a Facebook Messenger chatbot with Amazon Lex and Lambda, Step-by-Step Guide. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction. The rise of AI-powered chatbots has revolutionized how businesses interact with their customers. With its vast user base, Facebook Messenger is a prime platform for deploying chatbots. This podcast will walk you through creating a Facebook Messenger chatbot using Amazon Lex and AWS Lambda. By the end of this podcast, you'll have a fully functional chatbot integrated with Facebook Messenger, capable of efficiently handling user inquiries. Designing your chatbot, creating intents with specific user goals. The first step in building your chatbot is to design its conversational flow. In Amazon Lex, this is achieved by creating intents, specific actions or goals the user wants to accomplish through the chatbot. Each intent is associated with utterances, phrases users might say, slots, variables the bot collects, and fulfillment logic. Identify the core use cases. Identify your chatbot's primary goals. Whether answering FAQs, booking appointments, or providing personalized recommendations, each goal will become an intent in your LexBot. Create intents in Amazon Lex. Within the Lex console, create a new bot and add intents that align with your identified use cases. For example, if your bot is designed to book appointments, you might make an appointment booking intent. Define utterances. For each intent, define how users express their goals. For instance, for the appointment booking intent, utterances could include "I want to book an appointment," "schedule a meeting," or "can I reserve a slot?" Configure slots. Slots are information your bot needs to fulfill the user's request. For example, when booking an appointment, you might need to collect the user's name, preferred date, and time. Define these slots in your intent configuration. Set fulfillment options. You can set up your bot to fulfill the intent directly within Lex or call an AWS Lambda function for more complex processing. You'll likely use a Lambda function for dynamic responses or back-end integration. Lambda function implementation. Developing and testing your bot's logic. With your intents in place, it's time to implement the logic that drives your chatbot. AWS Lambda allows you to run back-end code responding to your LexBot's requests. Create a Lambda function. In the AWS Management Console, navigate to Lambda and create a new function. Choose your preferred runtime, Node.js, Python, etc., and configure the necessary permissions to allow Lex to invoke the function. Write the logic. Implement the business logic that handles the user's request. For instance, in the appointment booking intent, your Lambda function might query a database to check available time slots and confirm bookings. Test the Lambda function. Before integrating it with Lex, test your Lambda function independently to ensure it behaves as expected. You can use test events within the Lambda console to simulate different scenarios. Integrate Lambda with Lex. In your LexBot's intent configuration, set the fulfillment option to AWS Lambda function and select your newly created function. This will enable your bot to execute the Lambda code when fulfilling user requests. Lex integration. Building and testing your chatbot within the Lex framework. With your intents and Lambda function ready, the next step is to integrate everything within the Lex framework and test your bot. Test intents in Lex console. Use the test window in the Lex console to interact with your bot. Test each intent by typing different utterances and verifying that the bot responds correctly. Ensure that slots are filled as expected and that the Lambda function is triggered when needed. Handle errors and edge cases. Review how your bot handles unexpected inputs or incomplete information. Implement validation checks and prompts to guide users back on track when they provide incorrect or insufficient data. Refine the user experience. Based on your testing, adjust the prompts, responses, and overall flow to create a seamless, user-friendly experience that anticipates and meets user needs effectively. Facebook Messenger deployment. Connecting your chatbot to the Facebook platform. Once your chatbot is fully functional within Amazon Lex, the next step is to deploy it on Facebook Messenger, where it can interact with users in real time. Set up a Facebook app. Go to the Facebook for Developers site and create a new app. Under the Add a Product section, select Messenger and follow the prompts to set up your Messenger bot. Generate a page access token. Link your Facebook page to the app and generate a page access token. Lex will use this token to send and receive messages through Facebook Messenger. Configure webhooks. In the Messenger settings, set up a webhook to handle incoming messages. The webhook will trigger your Lexbot whenever a user sends a message to your Facebook page. Integrate Lex with Facebook. Configure your bot to connect with Facebook Messenger using the page access token and webhook URL in the Lex console. You may need to use AWS API Gateway to manage the integration. Test on Facebook Messenger. After setting up the integration, test your bot directly on Facebook Messenger. Interact with it as a user would, checking that it correctly handles all intents and scenarios. Conclusion and future explorations, recap and next steps in your chatbot journey. Congratulations! You've successfully created a Facebook Messenger chatbot using Amazon Lex and Lambda. You've learned how to design intents, implement logic with AWS Lambda, integrate your bot within the Lex framework, and deploy it on Facebook Messenger. As you continue your chatbot journey, consider exploring advanced features such as natural language understanding, NLU, improvements, multi-channel deployment, and integration with other AWS services like Amazon Poly for voice interactions. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.